Hey listeners, a quick word before we start the show. It is Canary Media's birthday. That's right, Canary Media and Postscript Media are partners on these podcasts. They're turning one this week, and to celebrate, they're having a party, a donation party, and we're asking each of you to bring a gift. If you don't already know, Canary is a nonprofit news organization. Part of their funding comes from listeners like you, and your financial support ensures Canary's newsroom continues to cover the solutions to the global climate crisis, and it ensures podcasts like The Carbon Copy and Catalyst have a home. So please take a minute to go to www.canarymedia.com and click on the donation button today. We've got a link right there at the top of the show notes. Be part of the solution to the climate crisis and sustain fact-based reporting on the energy transition, because if not now, then when? And happy birthday, Canary Media. Let's make sure there's many more. Thanks.
From the studios of Postscript Media and Canary Media.
I'm Shail Khan, and this is Catalyst.
Some people think, plant-based is really kind of a bridge to get us to a totally cultivated meat future, because there's just some sort of evolutionary X factor that really drives us to crave meat as humans. And then you'll hear other folks who think that cultivated meat is simply a bridge to get us to a plant-based future, but that cultivated meat won't be necessary.
This week, a healthy diet of technology wonkery around alternative protein.
Let's face it, environmental news is often very depressing. That's why we focus on solutions on this podcast. But still, the climate crisis looms large. Rising temperatures, mounting pollution, environmental degradation, they're all warping the planet. And for a lot of species, including us, things don't always look so great. But the story doesn't end there. Every Friday, Living Planet, a show from Deutsche Welle, takes you behind the headlines to figure out what's happening and how we'll get through it. It'll also help you make better choices for a healthy planet and find space to reconnect with the beauty and wonder of the world around us. You can find Living Planet wherever you get your podcasts.
I'm Shail Khan. I'm a partner at the venture capital firm Energy Impact Partners. Welcome. First, a little announcement. We're going to try something new here. I'm going to host an Ask Me Anything episode where I answer all of your questions, big and small, about climate tech and the energy transition and really anything else you want to ask me about, my childhood as a juggler, etc., though I'd prefer to mostly talk about climate tech. To send us your question or questions, just tag us on Twitter or on LinkedIn with the hashtag AskCatalyst. That's hashtag AskCatalyst. Do your worst, Energy Twitter. I'm ready for it. And stay tuned for more. Okay, so breaking the fourth wall a bit here, I have a few archetypes of conversations that I like to have on this show. One type I call WITH, which is a bad pronunciation of the acronym for what the hell is happening here. But another type is the Battle Royale episode. In markets where there are competing pathways to decarbonize the same product, I'm always wanting a clear handle on the tech stack surrounding each pathway and then the trade-offs that it carries. That's sort of how I feel about alternative protein. At this point, we all know that protein, and particularly beef, is a huge climate problem. There are some solutions that can minimize emissions while we continue to eat the same beef that many of us know and love for a long time, things like dietary supplements for cows to reduce methane emissions. But then there's alternative protein. It comes in multiple forms, and there's a vibrant and raging debate about which of these will win out in which situation. So here we are, the alternative protein battle royale. It's plant-based versus microbial fermentation versus cultivated meat. Get ready. Our tour guide here is Liz Specht. Liz is the VP of Science and Technology at the Good Food Institute, and as you will see, an absolute expert on this subject. So, with no further ado, Liz Specht. Liz, welcome to Catalyst.
Hi, Shail. Thanks for having me on.
Very excited to have you and to talk about alternative protein with you. Okay, so let's start high level. Can you kind of orient us on the state of alternative protein today and how that's changed over the past, 5, 10 years?
Yeah, so we've definitely seen an inflection point, and I feel like 5, 6 years ago is when that really started to take off. That's when I think probably sort of average consumer might have noticed the rollout of products like the Beyond Meat Burger and Impossible Burger that really sort of marked the emergence of what we call sort of next gen alternative protein or plant based meat products. So not the sort of old school veggie dogs or black bean burgers of yore, where they weren't fooling anyone into thinking they were meat, but really companies that are trying to truly mimic the full sensory experience of meat products, and the same thing is happening in the dairy sector. So this is a field that's still relatively small when you look at share of market relative to conventional meat. Right now in the U.S., which is where we have the best market share data, plant-based meats are at somewhere around 1.5% of the total meat market, but plant-based milks are closer to 16 or so percent of the total fluid milk market. Slightly different numbers, of course, for things like cheese and cream cheese and things like that.
Yeah, that's interesting. So we're at like 1.5% today. It feels like there have been a bunch of inflection points recently, or at least big milestones, and in this steady march toward alternative proteins. Maybe most notably, places like Burger King and McDonald's starting to carry alternative proteins. That feels like it's all in the past couple of years, really, right? So it started to pick up maybe 5 years ago, but really we seem to be hitting this kind of inflection point in the curve just in the last couple of years, it seems.
Yes. And another really big trend that's been happening, again, I'd say probably last 3-ish years, is the big major meat companies jumping into this space. And not sort of with curiosity or trepidation, but launching their own plant-based meat brands under their flagship brands, or creating new product lines, investing in or wholesale acquiring some of these plant-based meat companies, making investments into the cultivated meat space as well, including just last year a really huge $100 million investment from JBS, the world's largest meat company, into a cultivated meat company from Spain to acquire it and launch an innovation facility. So I know we'll get into sort of, everything that's under the umbrella of alternative proteins, not just plant-based, but cultivated and fermentation. But we're really starting to see that traction in terms of who's paying attention to this field. It's not just little startups and folks kind of tinkering anymore. There's really big player involvement now.
Yeah, and I think what we want to spend most of our time on today is actually talking through those various approaches to alternative protein and what the actual technology behind each of them is and what their strengths and weaknesses are. But let's first maybe just talk a little bit about what's driving this. Obviously, there's some combination of factors that are creating all this demand right now. Some portion of just consumer demand. There's climate change concerns. There's a push from the industry. So there's food security issues most recently. Like, what's your sense of the factors that are driving this inflection point?
Yeah, so I think there's a number of factors. So in terms of the motivations, I think the strongest ones on sort of a global good level are certainly the climate and environmental benefits. We're looking at basically 20% of contribution to global greenhouse gases coming from the livestock sector, and that's of course something that's worth paying attention to. There's also really substantial public health benefits associated with moving away from animal agriculture. A recent UN environment report titled The Next Pandemic, or Preventing the Next Pandemic, identified intensive livestock agriculture and growing demand for animal protein as two of the 7 biggest drivers for risks of zoonotic diseases, which of course are viruses or other infections that emerge in animals and then make their way into human populations, which I think, of course, is more top of mind for all of us now than ever. And then I think there's a lot to be said from a strict kind of market efficiency and resiliency and food security perspective. We saw a lot of the slaughterhouse shutdowns during COVID that really demonstrated how vulnerable these traditional animal agriculture supply chains are to those types of disruptions. And so there's a huge economic advantage and market advantage to folks moving towards alternative platforms that are just more robust, more resilient, less prone to those sorts of volatility and disruptions, and more quickly responsive to shifts in consumer demand.
Right. So for whatever reason or set of reasons, I suppose, this is happening now, but it's not uniform. So I guess the three primary pathways, currently at least, for alternative protein, just listing them, there's plant-based, there's microbial fermentation, and then there's cultivated meat or cultivated dairy. So let's take them in that order. I'm starting with plant-based, which, as you've talked about, is sort of the most mature and biggest currently. I'm curious, actually, what portion of that 1.5% is currently plant-based?
That's virtually all plant-based. So we'll talk about kind of technological maturity for these other categories as we get through them. But you can basically count cultivated meat out in terms of market penetration right now. It is being sold in one market. But almost all of that current product availability is on the plant-based side of things. There are a couple of products in fermentation, and we can chat about those. But plant-based certainly has had the longest history. And here, just to kind of define it, when we're using that term plant-based meat, we're really, again, talking about the types of products that are meant to serve as these sort of drop-in replacements for actual animal products and are intending to serve that consumer sensory experience. So not things like tofu and tempeh, which, are consumed by a certain segment of the population, but aren't really kind of making inroads with true omnivores or folks who would consider themselves flexitarians or reducitarians. So folks who like and want the taste of meat, but are looking for more sustainable or healthier choices as a couple of the main drivers here.
Right. And so obviously the best known names in this category are Impossible of the Impossible Burger and Beyond Meat. Those are clearly the first two that hit the public consciousness, I think, and are really starting to gain mainstream adoption. So what is their technique? Like, what is their technology? Impossible Burger and Beyond Meat and all these sort of new wave of plant-based meats. What are they doing to produce their product?
Yeah, I mean, a lot of it is just kind of putting in the R&D dollars to figure out what is that whole flavor palette in a meat product, and how are we recapitulating that sort of molecule by molecule from plant-based ingredients. If you think about what meat is, it's really just a combination of proteins and amino acids. It's got fats in there. It's got various biomolecules that contribute to flavor and aroma. And none of those are necessarily kind of unique from a functional perspective or a sensory perspective to animal-derived tissues. We can find pretty good proxies for all of those types of ingredients in the plant kingdom. So it's really just going through the sort of optimization efforts to rebuild that sensory experience, kind of component by component or ingredient by ingredient, into these newer products. Now, there are certainly some innovations that kind of enable that. So the Impossible Burger, for instance, their sort of flagship ingredient is this heme protein that they're producing through fermentation. So that's a nice kind of example of these hybrid products that are leveraging multiple of these alternative protein production platforms. But a lot of the sort of newer innovations that are kind of driving interest in plant-based meats are also around the texturizing processes. So things like high moisture extrusion, where you're getting these longer sorts of fibers out of plant proteins that are more representative of what you'd expect to find from animal muscle tissue, rather than being stuck with just these sort of ground meat, processed meat types of products.
So given all the progress on this side, what's the limitation? I mean, now we have Impossible Burger and Beyond Meat and a bunch of others. They're pretty good already. They seem to be getting better. There's all this work on texturizing them more like traditional meat. Presumably that will continue to improve. What's the ceiling on these plant-based approaches? In other words, we're about to talk about some more new approaches in microbial fermentation and cultivated meat. Why even go down those roads? Why not just stick with improvement on plant-based?
Yeah, so plant-based products, actually, there's a lot of low-hanging fruit still, and unexploited territory from an R&D perspective. One of the things you'll find pretty quickly if you look across ingredient labels for these products is almost all of them are working with a pretty limited ingredient stack in terms of where those primary proteins are coming from. So almost all of them are either soy protein based or wheat protein based, or a fair number in this sort of latest generation of products are pea protein based, but that's just a small number of all plant proteins out there. And those are the proteins that tend to be, available as concentrates or isolates, which tend to perform pretty well in these sort of structuring processes. But they're not necessarily the best ones for this application. They're just out there available at commodity scale. And so there's a fair bit of work to be done on sort of that crop selection and crop optimization side of things to just identify either cultivars of these major crops or newer crops or more niche crops like members of the pulse and legume family that might provide better innate functionality, by which I mean sort of the food science properties, like how well do these proteins bind water and fat so that you can have a nice juicy product rather than something that feels a little dry or a little stiff. How well do these proteins cross-link with each other, or so-called gelling capacity that gives you that sense of a sort of, highly structured, integrated product, not one that sort of falls apart in your mouth. So different protein sources and different crop varieties perform really differently on these various parameters, as well as the extent to which those parameters can be influenced by the way that those crop ingredients are processed and fractionated. So anytime you're harvesting a crop, you end up with, typically we're working from beans or seeds here that have some amount of protein, anywhere from, let's say, 18 to 50% protein. But then you've also got oils or fats in there. You've got a fair bit of starch and fiber in there, and different ways of milling and then fractionating those different biological components out of that raw material give you really different properties on the downstream side of things. And that's really important for these product developers to be able to make a compelling formulation.
Right. So I guess you're saying there's more work to be done and much more improvement to be had. But I guess, again, my question is, why not just do that? Is the idea that there is some limitation we're going to face in scaling up and improving plant-based proteins such that we need to spend more time on things like fermentation and cultivated meat?
Yeah, so it's kind of a mix of, we don't quite know where the ceiling is. We don't know, to what extent across every product category could plant-based products truly fool even the most discriminating consumer. Cultivated meat, the advantage there is that it is essentially identical to animal muscle tissue. So those cells are producing the exact same suite of proteins, the exact same suite of lipids. You can't get any closer to the real thing. It is the real thing. And so we don't quite know what that ceiling looks like for plant-based. In the fermentation realm, a lot of the advantages are really from this sort of enabling capacity, right? So producing some of these so-called superstar ingredients, like that heme protein, or there's other companies making specific dairy proteins, for example, casein proteins or whey proteins, that just have really innate high value functionality that's hard to find in the plant kingdom. Not to say it's not out there, but we haven't necessarily found proteins yet that perform quite as well in some of those applications. So these are kind of hacks to get us closer to true sensory mimicry, or even surpassing the sensory quality of conventional meat products. And then there's sort of the consumer element as well. If you poll consumers and say, are you interested in trying plant-based meat products if we can guarantee that they'll taste the same, or they'll cost the same or cost less. There's some fraction of consumers who just say, I'm not interested in plant-based meat. I want the quote unquote real deal. And so the advantage of kind of pursuing all of these approaches in parallel is that we're sort of developing a menu of options rather than putting all of our plant-based eggs in one basket, so to speak. And also recognizing again that these products will increasingly lean into this hybrid category where, you may have a predominantly plant-based product, but it's using a couple ingredients from fermentation, and maybe it's combined with, cultivated fat cells because that particular fat profile can be really hard to mimic from the plant kingdom.
All right, so we've alluded to the other categories that we want to get to in more detail, but I guess first, final question on plant-based. You talked briefly about cost. I am curious about cost. Where are we in terms of the cost of plant-based protein today relative to traditional animal protein, and what drives that cost? Is it feedstock cost to the plants? Is it the processing cost, or is it some other thing?
Yeah, so the cost of plant-based meat products right now it currently sits at usually anywhere from 2 to 4x on a per pound basis relative to conventional meat. And relative, I should say, to sort of, cheapest commodity versions of conventional meat. So it's often on par with sort of higher end or premium meats like grass-fed or organic or those sort of specialty meats. But that is, a price premium for these products that not all consumers are willing to pay. In fact, relatively few of them are. The biggest answer to your question of why does that difference exist is simply this disparity in scale. The animal agriculture industry has had 100 plus years to become extremely consolidated, extremely big, tapping into massive economies of scale, and is 100% commoditized, right? Whereas the plant-based meat industry, that 1.5% of the market is divvied up among several companies versus conventional meat is really, 4 main players for the most part. And each of those companies are manufacturing at a scale that's orders of magnitude smaller. So all of their ingredient procurement, they're not tapping into the same efficiencies. All of their manufacturing processes and throughput and so forth are nowhere near that scale. But there is certainly, room for bringing down the cost of even the raw materials further. Just to give one example, I mentioned soy protein as something that goes into a lot of these products. There's one company that's working on a high protein variant of soy that would allow companies to be able to use whole soy flour rather than going through the processing steps of getting to a soy protein concentrate or a soy protein isolate, because that flour would be at a high enough protein content that it can go straight into these extrusion processes that I mentioned that do that texturization process. So something like that could lop off, a whole set of unit operations from the manufacturing process and can further improve costs beyond just these sort of efficiencies of scale.
All right, let's move on from plant-based to category number 2, which we've talked about a little bit already because, as you said, there's a bunch of hybrids going on. But let's talk about fermentation. First of all, why don't you explain fermentation for us at the high level, and then how it's being adapted from all the traditional fermentation processes that we're used to, how we make beer, cheese, et cetera, wine, to this new world of alternative protein?
Yeah, so fermentation is kind of a fraught term. It depends what field someone's in that you're talking to them about, whether they'll agree with this definition. But how the alternative protein field uses this term is essentially any ingredient or product that's made through the growth of microorganisms. So that could be bacteria, that could be microalgae, that could be fungi. It could even be archaea. There's now one alternative protein company using an archaea, so a totally different branch of the tree of life. And there's a few different ways in which fermentation is used in alternative proteins. The first is what I'll call traditional fermentation. So this is most similar to what people think of with, kimchi or cheeses or tempeh or something like that, where you're essentially using the growth of these microbes on some sort of a plant-based feedstock as a means of processing and sort of enhancing that material. So in endowing it with additional flavor profiles, improving the digestibility or the nutritional properties, or improving some of those functional properties, such as its solubility or its water holding capacity. So there are some examples of folks using fermentation in this way to improve the properties of plant-based ingredients, so like plant proteins. There's one company called Mycotechnology based in Colorado that's actually partnered with JBS, one of the big meat companies, to launch a line of products under a brand called Plantera. That is using fermentation of essentially the mycelia of shiitake mushrooms to help improve the properties of rice and pea proteins. And then they're using that rice and pea protein in those plant-based products. The second category is what I'll call biomass fermentation. So where the whole ingredient that you're harvesting from that fermentation process is the whole cell mass of, usually this is done with fungi, but there are examples of bacteria being used in this way as well. So this is a really efficient process because a lot of these microbes are super efficient feedstock converters. So they can accumulate biomass very, very quickly and very efficiently, including from some pretty low value sort of side stream or waste stream sources of feedstocks. So companies in that realm, sort of the classic that's been around for decades, would be corn. But there's quite a few new companies launching in that space. Companies like Meaty and Nature's Find and so forth that are commercializing new strains of microbes for those sort of whole biomass applications. And then the third example is what we call precision fermentation. So this is where you're using the microbe not for its own sake, but sort of as a vehicle to serve as a mini manufacturing facility for a much higher value ingredient. So this would be like the heme protein in Impossible Burger, a number of enzymes that could be used to enhance protein functionality, etc. So these are kind of the lower volume, high value applications of precision or of fermentation that can be applied across the spectrum. They can go into plant-based products. These are also critical to produce some of the media components in the cultivated meat products we'll talk about.
I keep hearing that we're headed into or are already facing a major capacity shortage of bioreactors that would be a significant problem. I mean, if we're trying to scale this fermentation approach up to the size of the global food market, we need massive amounts of fermentation capacity, bioreactors that are in the tens of thousands of liters, and we need, I don't know, thousands of them, millions of them. But it seems like, at least at the moment, that's a bottleneck on growth. Does that ring true to you? And if so, why?
Absolutely. Yeah. And I think the industry is kind of waking up to this as a pretty severe bottleneck. There have been sort of a flurry of companies that are in, I would say, R&D into sort of early pilot scale phase. And then relatively few partners or co-manufacturing facilities to go to once these companies are ready to go to scale with their ingredient. We have seen, new facilities being launched, not quickly enough. I think by our count, there were 11 new facilities that came online in 2021. A majority of those actually were for biomass fermentation. So it's exciting to see additional scale happening on that front. But this will definitely be a crunch for the industry, and one where, there may be some R&D approaches to sort of mitigate this infrastructure shortage in the near term. For example, if you can, double your cell density of how closely packed these cells will tolerate being in a bioreactor, then that's essentially equivalent to doubling your infrastructure. So there's a couple of hacks kind of more on the biology side of things that can help make up for this shortage in the near term. But I think this really speaks to a need for the alternative protein industry to be reaching out to deep deep-pocketed, more kind of infrastructure institutional investors reaching beyond the sort of venture capital space where this industry has played mostly so far, and really kind of make the case for this very obvious growth in demand for new infrastructure and new facilities to come online.
Is the infrastructure complicated? Like, is fermentation is just basically done through big steel tanks with a bunch of ancillary equipment? I know I'm simplifying it, but essentially that is true. Is this type particularly high tech biomanufacturing? Presumably, precision fermentation is more high tech than at scale biomass fermentation. I know there's cases where you have bigger issues with sterility and things like that, but like how hard is that manufacturing channel? And will this otherwise just get solved by, as you said, traditional infrastructure investors just scaling up capacity?
Yeah, I think one of the big opportunities for the alternative protein space is to make it as low tech as possible. And there's a few examples of companies doing that already. So one example is the company Nature's Find that I mentioned earlier. They're working with a really cool organism that actually emerged from NASA-funded research in looking at extremophiles in the hot springs of Yellowstone National Park. So the organism they're working with grows at incredibly high temperatures, which is not good from an energy perspective, but they don't require high temperatures. They'll grow at room temperature. But importantly, they tolerate super acidic environments. And so you can grow those organisms essentially out in the open, almost on cafeteria trays, if you look at their production environment, and have no closed containment because you don't get contamination. These are kind of the only organisms that are just sort of out and about in the air that will grow in that environment. So there's examples like that of how we can make what used to be pretty infrastructure and also kind of operationally intensive facilities, because you're sort of fighting that uphill battle against contamination, and knock those back quite a few notches by working with organisms that lend themselves much better to sort of low-tech environments. Another advantage on the precision fermentation front is that you don't need the same levels of purity of those downstream end products as you would for kind of, historical uses of precision fermentation, which would be like enzymes or the biopharmaceutical industry, where you're going to inject an antibody or a drug into a patient. You need incredibly high purity, and that downstream purification is almost all of the cost of manufacturing those types of things. That's very different from the food space, where we're talking about an ingredient where it's okay to actually have some of the leftover, say, fungal or bacterial cells in that ingredient, because those host organisms are food-approved organisms. They're things that we might otherwise find in, a probiotic pill, for instance.
Okay, so what else is still to come in microbial fermentation?
Yeah, I think one of the things that's noteworthy on fermentation is that right now, companies working in this space are working with a very, very small subset of all possible microbial organisms. And that's one of the really powerful aspects of fermentation as a solution here, is that there's enormous biological diversity. You can find a microbe that makes almost any molecule you're interested in making. And so I think there's a lot of room for just sort of greater efforts to kind of canvas that biological diversity and find new bioproducts, new potential flavoring ingredients, new enzymes that could prove really valuable in this sector that we haven't even landed on yet.
Okay, so let's move on to the newest, fanciest, I guess in my perception, strain of alternative protein, which is cultivated meat or cultivated dairy. People have probably heard about this one. I think the layman's term that is often used is lab-grown meat. But what's actually happening when we are cultivating actual meat or dairy in a lab?
Yeah, lab-grown meat is sort of the term that causes folks in this industry to cringe the most. But yeah, cultured meat, cell-based meat are definitely terms that certain players are using. Cultivated is the one that's recently sort of emerging as a term that both makes this process familiar and approachable to consumers, but also kind of describes what's going on, which is really the process of cell cultivation or cell culture. So this is essentially growing all of the various cell types that comprise actual meat products. So predominantly muscle cells, fat cells, also some cells that contribute to the connective tissue. So cells like fibroblasts may be in certain types of products. And essentially assembling these cells into a spatial arrangement and getting that muscle fiber alignment such that you're creating a genuine meat product without the animal involved. And this is building off of decades of work in the biomedical engineering and tissue engineering realms, mostly for the purposes of things like organ regeneration and testing of biopharmaceuticals. So this is kind of building on all of those advances and now saying, okay, what does it take to get to cost parity? Is that even possible? And what does it look like to do this on the scale of millions of metric tons rather than somewhat small scale batches of biopharmaceuticals?
So I think my initial reaction when I started hearing about this stuff, as probably with many people, was like, is this a bridge too far? Not necessarily from an ethical standpoint or anything like that, but do we actually need to go through all of the effort and the scientific innovation it's going to take to cultivate actual cell-based meat in a lab? Like, do we so desperately need to replicate exactly the experience that we were used to in eating traditional meat? Or are we going to be able to create something that mimics it closely enough and then, to your point, maybe surpasses it using plant-based meat or microbial fermentation or some combination of those two? Like, what's the overall thesis behind the cell-based meat industry that is quickly emerging? Is it that really the only way this is going to scale to a global impact is if we just sell the same exact thing, albeit produced in a different manner?
So I think there's enough evidence that a significant fraction of consumers do want the, again, quote unquote, real deal. That it's worth pursuing. It's worth having in this portfolio. If you talk to folks who are looking kind of long-term future, I feel like I meet as many people who feel one inclination of like, what does 2100 look like in terms of our meat source versus others who feel the exact opposite. So some people think, plant-based is really kind of a bridge to get us to a totally cultivated meat future because there's just some sort of evolutionary X factor that really drives us to crave meat as humans. And then you'll hear other folks who think that cultivated meat is simply a bridge to get us to a plant-based future. We all grew up eating conventional meat. That flavor profile is kind of imbued in our culture and in sort of our ingrained taste preferences. But that eventually, as we get closer and closer facsimiles to meat from the plant-based world, or even just kind of move past this concept of mimicry altogether, that cultivated meat won't be necessary. I tend to think that both of these approaches will continue to be attractive to different groups of consumers for different reasons going forward, and particularly for some of the more nuanced flavors. Things happening in the seafood realm come to mind. Really nuanced flavors or textures or just sort of a layering of sensory properties that contribute to these whole muscle cuts is much harder to imagine replicating with really high fidelity from plant-based approaches, in my mind. Not to say it's impossible, but if you think of, heterogeneous whole cut products, think of like the quintessential is a marbled steak, right? It's hard to sort of think of a manufacturing approach in the plant-based realm that would quite get us there. Whereas if you're, working with a scaffold where you've got some sort of patterning and you're kind of directing cells in certain spatial areas to differentiate into muscle and cells in other areas to differentiate into fat, that's something that these cells sort of innately know how to do, right? They spent millennia evolving to be able to produce those sort of heterogeneous, dense, whole cut structures. So I think for ground meat products or processed meat products, it very well may be the case that there's really not a market for cultivated meat in those types of categories. But I think it's really for these whole cuts that will be sort of, the last 25% or so of the market for us to be able to really kind of satisfy, where cultivated meat seems like it might just offer innate advantages that it's hard to envision how plant-based would be able to make it all the way there.
We talked about costs when we were talking about plant-based. We actually, I think, skipped over it with microbial fermentation. So going back for a second, I'm curious where we are from a cost perspective there relative to plant-based. And then what do we know about the cost of cultured meat at this point and the trajectory that it might be on?
Yeah. So for fermentation, it's pretty product dependent. And again, depending which of those categories we talked about, traditional, biomass, precision. On the precision fermentation front, you can get purified proteins and enzymes and so forth in the ballpark of, dollars per kilogram. For really large-scale commoditized processes. So that, I think, is sort of a reasonable kind of floor for what that might look like. And again, that might get cheaper if we tolerate lower purities and thus less stringent sort of downstream processing for those precision fermentation ingredients. For biomass fermentation, the price points right now, in terms of what they're selling at commercially, look really similar to plant-based, but I think that's mostly sort of an artifact of that's what they're benchmarking for from a sales perspective. There's potential here to be really low cost, again, just because these efficiencies are really high, and there's a potential to use really low value, low cost feedstocks as primary inputs to those processes. We haven't yet done or seen a lot in the way of techno-economic analyses for something like biomass fermentation that really kind of forecast that out. But I think it's quite likely that those processes could pretty significantly undercut the price of even plant-based meat. And then for cultivated meat, it's hard to get a barometer on where true production costs are now. You'll see numbers, thrown out by startups in the media that I always take with about a kilogram of salt. But it's clear that there is a path to something that approaches price parity when you run these sort of hypothetical, forward-looking techno-economic analyses. So there was a study that came out last year from a consultancy called CE Delft that looked at a few different scenarios for cost reduction and found a path towards getting in the sort of single dollars per kilogram range. And that agrees with internal techno-economic analyses performed by a number of these companies. But we're still, certainly we're further from that than we are for either plant-based or fermentation. And again, this is something where I think the food sector has a lot of advantages relative to other biotech sectors, like fuels or chemicals or things like that, where those are true commodities. No one's interested in your product unless you're producing at, thousands of tons at a time, and very few people are willing to pay a price premium for those. By contrast, something like cultivated meat, you can go into product categories like sushi or sashimi and make a 3 millimeter thick slice of meat tissue and sell it in a really high-end restaurant as kind of your go-to-market scheme. And you have sort of this march towards market penetration that simply doesn't exist as sort of a handhold or a bootstrapping mechanism in some of these larger commodity non-food industries.
Yeah, that's a really key point. There's a wedge into the market where you can sell at a significant premium where cost may not actually matter all that much, but quality really, really matters. And then you can sort of move down the cost stack from there. That's, I think, also been true in many of the other more successful biotech applications like in pharma and biomedical.
And you see crossovers here as well. So jumping back to the precision fermentation space, companies like Geltor that's making precision collagen or recombinant collagen, they actually went to market in markets like cosmetics and biomedical R&D that uses collagen for things like tissue culture, for example, for scaffolds. So those are really high purity. They have a huge advantage by being able to kind of beat the quality assurance metrics relative to gelatin or collagen isolated from animal meat processing. And that's their sort of go-to-market foray as they then sort of build revenue streams and expand their infrastructure and their scale.
Okay, so talk me through what you think is going to happen over the next 5 or 10 years. Where are we going to see the most activity here? What are the big milestones that this industry is looking toward? And what should we be watching out for from a tech perspective?
Yeah, so I think we're starting to see a lot of traction finally after several years of plugging away at this in getting more enthusiasm and more buy-in on the public funding side of things to get research dollars flowing into this space in a way that's generating sort of an open access knowledge foundation, rather than all of the R&D happening within the private sector and, frankly, a lot of duplicated efforts across different companies in this space. So we're starting to see, national governments start to prioritize alternative proteins. In China's recent 5-year strategy, they called out cultivated meat explicitly as something that is a priority area. Just late last year, we saw the announcement of the USDA investing into the very first National Institute for Cellular Agriculture. So these types of sort of signaling events is part of their power, but also just the raw research dollars flowing into the space is really starting to shine a spotlight from a talent perspective onto the R&D challenges in this space. So if you could take, even 1% of the bright minds out there who are focused on biomedical or biopharma R&D challenges and get them looking at the challenges in this space, that will have really, really massive consequences for the rate of progress across all of these alternative protein categories. I think another big development will, of course, be on the regulatory front. So, as I mentioned, cultivated meat is only available in Singapore at the moment, but we know that is working its way through regulatory assessment and food safety assessment in multiple other countries at present. And then same on the fermentation side of things, getting approval for some of these precision fermentation ingredients, whether that's through a generally recognized as safe process or other processes like novel foods processes, depending on which country or region we're talking about.
All right, final question for you. If I have to go out and buy and eat one alternative protein product this weekend, what do you recommend to me?
Ooh, gosh. Do you want a milk or a meat product?
Oh, I'm all over the milk stuff already. We've got almond milk and oat milk and all that stuff in our house. So give me something in meat.
I think Impossible Foods products are probably among my favorites. I don't know if I'm allowed to say I have favorites. I actually just purchased for the first time Impossible's new sausage, not a breakfast sausage, but kind of a full, put it in a hoagie bun sausage that I have not tried yet, but we can try it together this weekend.
That's a good one for me. I grew up in Wisconsin, Madison, Wisconsin, which is home to Bratfest, which is the weekend-long festival where they generally try to set the world record for the number of bratwursts sold in a single weekend in one location every year, and they usually do break the record. And I have very fond memories of it. So if Impossible can replicate my nostalgic experience of eating bratwurst as a kid, then they will have done something pretty monumental, at least to me. But anyway, this is really informative. Thank you so much for taking the time. There's clearly a ton going on here, so I'm sure we'll have you back to talk about it again.
Thanks so much. It's been great being here.
Liz Specht is the VP of Science and Technology at the Good Food Institute. This show is a co-production of Postscript Media and Canary Media. You can find the show on Twitter at @CatalystPod, and you can also find me, Postscript, and Canary there too. Don't forget to send in your questions for the Ask Me Anything mailbag episode. Just tag us with the hashtag AskCatalyst on Twitter or on LinkedIn. And send us feedback. If you like the show, go over to Spotify or Apple Podcasts or wherever you get the show and leave us a rating and review, or just share the episode with a friend. You can find links for this episode's topic and guest in the show notes on canarymedia.com. Postscript is supported by Prelude Ventures, a venture capital firm that partners with entrepreneurs to address climate change across a range of sectors, including advanced energy, food and agriculture, transportation and logistics, advanced materials and manufacturing, and advanced computing. And I got that done in less than 15 seconds. The Producers for this episode were Daniel Waldorf, Dalvin Abuaji, and Stephen Lacey. Mixing by Greg Vilfrank and Sean Marquand. Theme song by Sean Marquand. I'm Shail Khan, and this is Catalyst.